Hello, I'm Ben Welsh, and you're back again for more First Python Notebook. I'm broadcasting for you live from Manhattan, USA. And here in this next chapter, we're going to cover another one of the fundamental skills of data analysis for both journalism and in Python and pandas. So that is merging. So one really common data challenge that is actually quite difficult to do in many of the spreadsheet tools like Microsoft Excel is to take two different data sets and to join them together into a common data table using a shared column. And so this is a very common operation where you have on the one hand a data set that has, say, for instance, as us does ours, the postal codes of all 50 states. Let's say you wanted to merge into that data set the full names of those states spelled out, like California for CA and New York for NY. Bringing those two data sets together using a common column, a postal code, is a really frequent challenge when working with data. That's a sort of simplistic example. We're going to use a real world one here in a moment. And that's the kind of thing that spreadsheets are bad at. But pandas and Python and other computer programming languages make that thing really, really easy. All it takes is two different data frames and one common column, one or more common columns, and boom, you can bring them together into a single set. And that was a challenge that I faced when working on this story, because we didn't just want to add up the total number of accidents. We wanted to be able to adjust the accidents based on how popular the helicopters were to calculate a rate that didn't allow the most popular helicopter to automatically come down as the most dangerous without taking into account that other factor. And this is a really common challenge in all data journalism when you're looking at something like homicides or murders. You know, some cities are bigger than others. And so in being able to compare the two, you often calculate a rate, right? How many homicides per person in each of those cities is then a better comparison to allow you to look at things on kind of the same scale. And so in our reporting, we heard this concern from people about Robinson, where it was actually pretty well known that the Robinson Helicopter Company had a lot of accidents among its customers, but it wasn't known what their accident rate was. And with Robinson being one of the best-selling helicopters, some thought that if you were to do an accident rate calculation, they wouldn't even come out that high. In fact, that was a claim of the owner of the company. And so we sought to take this on and to get to the bottom and to find the truth. In the course of our reporting, we learned that in the 1990s, the Federal Aviation Administration, the FAA, had actually done some accident rate calculations of their own, though it had been 25 years since they had been updated. And at that time, in reading those documents that were created at that time, we learned that the FAA conducts an annual survey of helicopter pilots, which attempts to estimate, as best as can be done, how many flight hours each pilot spent in the air. And if you think about it, how many hours that you are in the air in total for all pilots of a certain helicopter are a pretty good indicator of how popular the helicopter is and how much is it in the air. And this was, in fact, how the FAA researchers looked at it. And so they divided the number of helicopter accidents per make and model into the number of flight hours that each of those models spent in the air for the year, and then calculated a rate of accidents per flight hours. But it had just been so long since that had been done that the Robinson R-44 didn't even exist, wasn't even on the market at the time of the study. And so what we did is we set out to recreate that accident with newer data. One problem: the helicopter flight hour survey is not public. It's not posted on the FAA website. It's not put out in an annual report to Congress. It continues to be done year after year by the FAA via some consultants they hire, but it's never actually revealed. And so what I did is that I filed a Freedom of Information Act request. For those who don't know, the Freedom of Information Act, or FOIA, is a law that gives all Americans a right to request that their government give them documents that are generated on the public's behalf. And that can include data. Now, there are exemptions to this rule. There's things related to law enforcement investigations and people's healthcare privacy that are shielded from exemptions, including a number of other things, confidential records, top secret things in the military, for instance, at least for a certain period of time. But we felt that this record, a survey paid for with tax dollars, that's just all about what's happening in our shared and common airspace, felt like a record that was seemed pretty likely to be available. And so I filed a request and I followed up on it. And after months and months and months, I received in the mail a list of the annual survey results for about a decade from the FAA that gave for each year the number of flight hours that they estimated based on surveys of real world pilots, each make and model was in the air. And so that came to me as sort of 10 or 15 different PDFs that had sort of data tables that were printed out, not spreadsheets or anything electronic. You can find them in the GitHub repository I've linked to in the documents of all the real work that I did as part of the piece. They're available online. I then sat down and over the course of a day or two, key punched all those records into a spreadsheet. I created a database out of the PDFs that came back from the request. And then I used Python and pandas to aggregate those to create over a 10-year period the total number of flight hours associated with each make and model, right? And that ended up being 12 make and models that were common enough to appear over the entire data set in each year's survey results. There really aren't that many helicopters at the end of the day, at least ones that are common in comparison to cars or other more commonly manufactured devices. And so that became the denominator that we wanted to compare against our accident rates, our accident counts, to calculate a rate of our own. And so that data, again, which took a little bit of key punching and a little bit of analysis for me, right, prior to the actual sort of big moment of the merge, is available for us to pull into our notebook at another URL that I've prearranged, with the data having already been, I think, pretty well prepared and ready for analysis. So in the documentation for this chapter, you're going to see that there's another read CSV function, the exact same function we called in to bring in our accident list, that leads to another long URL, this one called FAA survey. And I just want you to paste that code in because this is too long to type. And we're going to save it into a variable called survey. If you do that, that'll then create, another data frame that we're going to be able to work with. I'm going to run one of our functions we learned very early on in the class called info to print out the report card about this database. And we see, yes, it has 12 rows, one for every make and model. Hey, there's that same column we saw in our other data set, LA times make and model. And there's a new column we haven't seen before called total hours, which has how much time there's in the air. So if I compare that to the info readout on our accident counts table, where we generated our condensed totals ranking, we can see that, yes, they have the exact same column, LA times make and model. And that's the kind of thing, just like in my example of the postal codes, where we could bring together two data frames using a shared column to create one big common table that has all the columns from both of them put together, right? And pandas has a built-in function for doing just that kind of join, and it's called merge. And so that PD variable, that handy nickname or shortcut from earlier, has right on there, whether you know it or not, among its many, many tools, a little function called merge. And so if we type PD merge, open parenthesis, close parenthesis, we just need to give it the names of our data frames, which, remember, we just called this one survey that we read in, and the function that's the result of our group by is accident counts. And so if I just give them those two variables, and then it expects us to tell it what column to add on or to join on. So I do another comma, and then I do on, which is a little keyword variable. This is a new Python thing. It's like an extra option. And then I give it the name of the column I want it to join on, which you could also copy and paste, just LA times make and model. And so all I've done here is I've called on the PD merge function, and I've given it two inputs. For a lot of things thus far, we've only given it one input, right? But here we're giving two inputs because there's two tables we want to join. And then a third thing is we're flicking this little option, and we're saying we want you to join on, or we want you to join using this shared column, LA times make and model. And so if we do this right, we should see a merged result that has all the columns from both together and still 12 records, right? Let's do it. Ah, it didn't work. So you can see here, we got back an empty data frame. Oh no. So this is not what you want. So we asked it to merge the two tables. We put it on the column, but they didn't merge. What's up? And so this is like, one of these frustrating moments that's going to happen every day when you're dealing with computer code is you think you've translated your question or your task into Python and then you don't get the result you want. You're like, what's wrong? Well, we looked at our tables and we saw they had the same column. So that seems right. Let's look at what's inside those. So let's do a head again. So remember accident counts. If we do head on that, okay, LA times make and model, Augusta, da 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 da. Okay, what about with survey? Do survey.head. Oh, hmm. So yeah, it's Augusta, but look, it's got this funny typing. It's almost like the person teaching your class got a little silly in the data. And yes, I did. So you can see here, I've introduced a flaw into my supposedly clean data set where, again, just like in our earlier cleaning example, we don't the names of the makes and models are not all uppercase. And so because the casing of this Augusta 109 and the casing of this Augusta 109 are slightly different, the merge is failing, right? And it's unable to link the records. And so the result of the merge, which is trying to only keep the records that match between the two, is that none of them match and none are coming back, right? And so that's a flaw in our data preventing us from doing the analysis we want. And so in this case, again, what we need to do is we need to clean up our source data set to be all capital letters. And we can do that just by repeating the exact same trick from earlier in the class, which is we're going to use the indexing trick to access the column, right? So, but this time we're going to use the survey variable because we're working with our second data frame here, not our first, right? We're going to say from the survey data frame, we're going to use the exact same indexing trick. And we see the space or the casing is all off. And then we remember that .str method. We're going to call on that again. The .upper method with the open and close parenthesis, we're going to call on that again. Now I'm going to hit play. We can see, okay, it's all caps. That's going to be the fix we need, I think. But now we want to save that to the column to overwrite what was there before. So again, we do the exact same thing we did before, where we say index this column and then using the equal sign, overwrite it with an all uppercase version of itself. And if you look at that real quickly and you scroll up and look at how we did that earlier, right? It's the exact same code up above when we did it before. It's just that the data frame is different with the different variable name, but the same operation, right? And so we actually didn't learn any new code. We just reapplied the same trick from before on a different data frame. Now, if I run that, very good. Now I'm going to take my merge method from above. I'm going to copy and paste it, and I'm going to run it below again. So this is the exact same merge method, right? PD merge, the counts to the survey on the column, the code's exactly the same, but we've edited the underlying data. Now when we play, boom, we see the result is we now have a combined table. The make and model column only exists once because it's in both, they can be combined. And we have side by side our accident counts and the total number of flight hours over that same about 10-year time period for each of those helicopters. And it's by dividing these two records together that we're ultimately going to run our analysis, right? And come up with our finding that we're going to share with our readers. And so before we can get into that and start calculating things that are a result of our work, we need to save this merge into a variable. And so I'm going to create a new one right here just called merged underscore list equals the result of that merge method, right? You could name it anything, but again, I'm doing merged underscore list to let me know what's happening here. It's the exact same code, and that's now saved into a variable. Boom. right? And after that, we've now learned how to use the merge method, and we're ready to move on to firming up our finding and trying to compute a rate that does not exist anywhere else in the world at the time of us first doing this, and seeing if our finding is strong enough to ultimately report.